Hello, Algebra 2 students. So today we're going to continue our study of quadratic functions, and we're going to look at transformations. And if you notice how the parent function changed, you can talk about what transformations or movement occurs. So remember from geometry, a transformation changes the position or size of a figure. Okay, and there's three types of transformations. We're going to look at translation, dilation, and reflection. Remember from geometry, the fourth one was rotation, but we're not going to worry about rotations for our quadratic function. So again, we're going to focus on translation, dilation, and reflection. So again, translation is when your figure moves left or right or up or down. It's a slide, okay? So if, and again, maybe I should say your parent function always looks like f of x equals x squared. That's the original parent function. And everything is going to be based on this movement. So if the graph of g of x is x squared plus k, again, the parent function is f of x equals x squared. That means your graph is translating vertically whatever that k is, so many units. So again, if my example would be g of x equals x squared plus 2. This means my graph is shifting up 2 because vertical is up or down. Since it's a positive 2, it would go up 2. Okay, so again, that's going, and if it's minus, so for example, if I had g of x equals x squared minus 3, that means your graph is shifting down 3. The minus at the end means it's going down. Okay, so notice it says here the value of the constant k translate or shifts the graph up one positive and down one negative, like I just said over here with these examples. Okay, now the graph can also shift left or right. If it shifts left or right, it looks something like this. So if g of x equals x minus h quantity squared, again, it's the graph of the parent function, f of x equals x squared. That means it's going to go horizontal. Horizontal is left or right. So the graph of h translates or shifts the graph right when h is positive. So there's going to have a minus in the middle here. So this particular shift would mean you're going right 2. So this would go right 2 if it was like squared. And then if it's negative, there's going to be a plus there. So this would mean it's going left. So left 3. And again, when we're at the end, we're going to have a combination of all of these. Okay, so translation is going to go left or right, up or down, and maybe a combination of them. The dilation is when the graph gets narrower or wider. And that's your A value out in front. That determines, remember we talked about if it's positive, it opens up. If it's negative, it opens down. It also tells you if it gets, again, wider or narrower. So that's whatever the A value is. Instead of saying wider or narrower, we say stretched, or we say compress, like a vertical stretch or a vertical compress. So it tells you, so if A value, if the absolute value of A is greater than 1, it's going to be a stretch. Specifically, we're going to say it's a vertical stretch. If the absolute value is between 0 and 1, it's going to be a compress. So again, if we do two quick examples here, if I say g of x equals 3x squared. So since 3 is greater than 1, this is going to be a vertical stretch. Okay, if I would say g of x equals 1/4 of x squared, you see how 1/4 is less than 1 but greater than 0. So this is going to be a vertical compress. And then the last type of movement here we can have is a reflection. A reflection is you're going to flip it across a line. Specifically, we're going to reflect across the x-axis is what we're going to focus on. And this basically is telling you if it's negative. Okay, if your A value is negative out in front, you're going to say it's a reflection across the x-axis. So what we're going to do next in just a moment here is we're going to put it all together and see if we can figure it out. But when you put it all together, you get vertex form. This is the vertex form. F of x equals a times the quantity x minus h squared plus k. So we've talked about standard form, and we talked about how to find the vertex and the axis of symmetry, get 5 points to plot it. But if it's in vertex form, it's a little easier to deal with here. So your vertex is h comma k. Your axis symmetry is going to be x equals h. Okay. Your domain is going to go from negative infinity to positive infinity. And your range is your y values. So if a is positive, again, your range, like I said, is your y values. So if it's positive, that means your graph is going to open up. So your range is going to go from k to infinity. And if a value is negative, it's going to go from negative infinity up to k. So something to keep in mind. We're not going to do that just yet, but that's a preview, again, of what's to come here. So again, if I'm looking at it, just putting it all together here. So my h value is shifting the graph left or right. My k value is going to shift the graph up or down. And then the a value out front is going to tell you if it's a vertical stretch or compress. And again, if it's negative, it's going to tell you that it reflects across the x-axis. So again, we're going to put all of these together and see what we can do here. So it says, describe how the graph of each function is related to the graph of f of x equals x squared. So again, it goes back to vertex form is a times x minus h squared plus k. Okay, so it's plus 3 at the end. So this plus 3 means we're going to translate up 3. So it's a vertical, again, vertical translation. We have g of x equals x squared minus 4. Since it's a minus 4, this means we're going to translate down 4. Okay, for this one, we have g of x equals the quantity x minus 2 squared. Since the 2 here is in the parentheses, and again, it's supposed to be minus to begin with, this means we're going to translate to the right 2. And since this one is a plus 1 in parentheses, this means we're going to translate left 2. Again, it's left because that's supposed to be a minus in the middle. If it's a plus, that's the opposite sign. Okay, so this one we have a 1/2 out in front. Okay, so this means it's going to be a vertical compress, because if it's a fraction between 0 and 1, it's going to be a compress. Since this one has an a value of 2 instead of a compress, this is a vertical stretch. So again, we're going to put a few more going on here. So again, same directions, describe how the graph is related to the parent function. So on this next one here, if we have g of x equals negative 2x squared, the negative means it's a reflection across the x-axis, and the 2 also means it's a vertical stretch. So again, these you're going to have a few more directions to give. Okay, so again, I have a negative out in front. So again, negative out in front means it's going to be a reflection across the x-axis. And then the 4 here means it's going to translate. And then inside the parentheses goes left or right. Since it's a minus, it's going to go right, in this case, 4. Okay, on this one, h of x equals negative x squared minus 9. So again, the negative out in front means, again, it's a reflection across the x-axis. And then the minus 9 out at the end, notice it's not in parentheses. That means you're going to translate, in this case, down 9. Okay, continuing on here, if we have g of x equals x minus 3 quantity squared plus 2. So this one's going to go in 2 directions. We're going to translate that 3 here means we're going to go right 3, and the plus 2 at the end means we're going up 2. Okay, on this next one we have h of x equals negative 4 times the quantity x plus 2 squared plus 1. So negative, this one's got a lot of things going on here. A negative means it's a reflection across the x-axis. The 4 means it's a vertical stretch. Remember, if it's greater than 1, it's a stretch. If it's between 0 and 1, it's a compress. The +2 here means we're going to translate left 2, and the +1 at the end means up 1. And if we do one more, so we have a third out in front, there's no negative, so it's not a reflection across the x-axis, but the 1/3 means it's a vertical compress. The +2 here means it's going to translate left 2, and the -1 at the end means it's down 1. So for today's worksheet, you're doing the same kind of thing. Okay, you're going to look at the equation for the graph, and you're going to tell me how it moves. So again, you're using the appropriate terminology, translation, reflection, and then for dilation, you're going to say if it's a vertical stretch or compress. If you have any questions, please let me know.